Hello everyone. Welcome back to my YouTube channel. In the last video, we have seen basic questions asked on the tray tower. Now, in this video, we will see important questions asked on packed column. So let's see questions. So the first question is, what is a packed tower? So, packed towers are vertical columns which have been filled with packing or devices of large surface. These towers are used for continuous contact of liquid and gas in both countercurrent and co-current flow. In a packed tower, the liquid solvent is introduced from the top through the liquid distributor, which wets the surface of packing uniformly. Then, liquid trickle down the bed, and finally the solute-rich solvent, called strong liquor, leaves the bottom of the column, and a solute containing gas is introduced from the bottom of the tower and rise upward countercurrently to the flow of liquid through the open spaces in the packing. Then the lean gas leaves the column from the top of the column. Now, what is packing? So, packings are small diameter structured, of varying size, and of various simple to complex geometric shapes. These are made of ceramics, metals, and plastics, and vary in size from 6 to 75 millimeters. Now, what is the function of packing? So, the main function of packing is to provide a large interfacial area for gas-liquid contact and for mass transfer between the phases. Now, what are the important characteristics of packing? So, the important characteristics of packing are: packing should provide a large interfacial area for phase contacting. Hence we get better separation. Packing should provide a large void volume or empty space in the packed bed. Packing should possess a good wetting characteristic. Packing should be relatively cheap or inexpensive. Packing should have a low bulk density. Packing should possess enough structural strength. Packing should have high corrosion resistance and chemically inert to the fluids handled in the tower. Now, what is meant by random packing? So, if packings are simply dumped into a tower during the installation and fall in a random fashion, is called random packing. To avoid breakage and for uniform voidage, a tower is first filled with liquid, and then packings are then dumped into it. Now, what are the types of random packing? So, The most common random packings are rasking rings. So, rasking rings are hollow cylinders with a length equal to the outside diameter. They are simple in construction and relatively cheap as compared to other packings. They are usually made up of ceramic, carbon, and metal. It available in a size ranging from 6 to 100 millimeters. Next is lacing ring. When a single web is added in rasking ring, it's called a lacing ring. Added web provide additional active surface. Next is cross partition ring. When the cross web is added in rasking ring, it's called cross partition ring. Next packing is burl saddles and interlock saddles. They are available in range 6 to 50 millimeters. This is made up of plastic or ceramics. They provide more gas-liquid contacting area than ration rings. Now next is teleret. It is available in the shape shown and in several modifications. It is mostly made up of plastic. Now next is ball ring. They permit a more economical tower design. They are replacing older rasking rings and burl saddles. Ball rings are made up of metal or plastic and have some general form as rasking rings with height equal to the diameter. They are generally available in sizes ranging from 16 to 50 millimeters. Now, what is mean by regular or stack packing? So, if packings arranged in a particular pattern are called stack packings. They offer lower pressure drops for the gas than random packings for equivalent phase flow rates. Now, what is the use of liquid distributor in packed towers? So, a liquid distributor is a device that spreads the liquid uniformly across the top of the packing. In the case of tall towers, liquid redistributors are used to redistribute the liquid and to avoid channeling. Now, what is the use of packing restrainers in the packed tower? So, packing restrainers protects from the lifting of packing during a sudden gas surge or when gas velocities are high. For heavy ceramics packing, heavy bar plates resting freely on the top of the packing may be used. For plastics and another lightweight packing, the restrainer is attached to the shell. Now, what is the use of packing support in the packed tower? So, in packed tower, packing rests on a support plate, which offers very low resistance to gas flow. It should be sufficiently strong, as it carries the weight of the entire packed bed. It must have a large free area for the gas and liquid phases. Now, what is the liquid holdup? So, liquid holdup means the liquid retained in the tower has films wetting the packing and is spool caught in the void between packing particles. Hence, total holdup is made up of phi Lt is equal to phi Lo plus phi Ls, where phi Ls is the static holdup. The static holdup is liquid retained as pools in protected interstices in the packing, largely stagnant, and slowly replaced by fresh liquid. On stopping the flow of gas and liquid, the static holdup does not drain. Phi Lo is the operating or moving holdup. The moving holdup means the liquid which continuously moves through the packing and continuously and rapidly replaced by new liquid flowing from above. And when gas and liquid flow stop, the moving holdup drains from the packing. Now, what is the loading point in the packed tower? So, the point at which the liquid holdup in the column starts to increase is called loading point. At this point, free area for gas flow becomes smaller, and the pressure drop rises more rapidly. Hence, from this point, the slope of the pressure drop gas flow rate relationship changes, because pressure drop increases more rapidly with an increase in velocity. Now, what is meant by channeling? So, channeling occurs when water flows down the tower wall, rather through the void within packing. At low liquid rates, much of the packing surface may be dry, or at most covered by a stagnant film of liquid, because the liquid to segregate towards the walls and to flow along the walls, rather through the void within the packing. Channeling, also defined as the unequal wetting of the packings in the tower. If channeling occurs, poor mass transfer happens, and therefore, less efficiency of the tower happens. Now, how to avoid channeling? So, methods to avoid channeling are: using smaller size packing can reduce the tendency of flow to the channel. The diameter of the tower should be at least 8 times the packing size. The good initial liquid distribution. Now, what is meant by flooding in the packed tower? So, flooding condition in packed column depend upon the method of packing and settling of the packing. At given liquid flow rate and high gas flow rate, a layer of liquid may appear at the top of the packing, and the entrainment of liquid by the gas leaving the top of the tower increases rapidly. Then the tower is called a flooded tower. At this condition, the accumulation of liquid is rapid, and the entire column may be filled with liquid, and most of the packing surface is wetted. Due to this, the gas-liquid contact area increases. The gas velocity corresponding to the flooding conditions is called flooding velocity. And for better operation, the tower should be operated below the flooding condition. Now, define HTU. So, HTU means the height of a transfer unit. It is a measure of the separation effectiveness of the particular packing or particular separation process. If the mass transfer is more efficient, that is at large mass transfer coefficient, the value of HTU will be small. Now, define NTU. So, NTU means the number of transfer units. The NTU is similar to the number of theoretical trays required for the tray column. It is a measure of the difficulty of the separation. A large number of transfer units will be required for a very high product. So, the height of packed towers is equal to HTU into NTU, where HTU is equal to height of transfer unit and NTU is equal to number of the transfer unit. Now, what is HETP? So, HETP means height equivalent to the theoretical plate. HETP is the height of the packing. That will give the same separation as one theoretical plate. Such that, in the section of height of packing, the vapor leaving the top of the section will have the same composition as the vapor in equilibrium with the liquid leaving the bottom of the section. It depends upon size and type of packing, flow rates of fluids, and concentration. The HETP is determined experimentally, and it is characteristic of each packing. Now, what are the merits and demerits of packed columns? So, merits and demerits of the packed column are: for liquid having a tendency to foam, packed tower are preferred. High values of the liquid-gas ratio are best handled in packed towers. Liquid holdup is low in a packed column, so they are used in a case where liquid deterioration might occur at high temperature. Pressure drop through the packed tower is usually low, which makes the packed tower particularly desirable for vacuum distillation operations. Packed tower may be more economical than plate towers when highly corrosive fluids are to be handled, because ceramic and plastic packings are corrosion resistant. Now, what is the difference between tray column and packed column? So, difference between tray column and packed column is: tray columns are stage-wise contactors, and packed columns are differential contactors. In tray tower, trays are used as a gas-liquid device. And in a packed tower, packing are used as a gas-liquid device. In tray tower, the pressure drop is large. And in a packed tower, the pressure drop is small. Tray tower provide larger liquid holdup, and packed tower provide smaller liquid holdup. In tray tower, very low liquid-gas ratio handled. And in a packed tower, high liquid-gas ratio handled. In tray tower, cooling of liquid is easy. And in a packed tower, cooling of liquid is difficult. So that's all about important questions on packed column. So, if you like my video, please like my video, share this video with your friends, and subscribe to my YouTube channel.